Hi, I'm Courtney. I'm going to be discussing some elements from Module 2, which was biological building blocks of the mind. And in particular, we will have a look at neurons and neural connection. So this was my mind map of the whole module, and we're going to zone in here on the neurons and neural connection. So neurons are information processing skills. There are around 86 billion neurons in each human brain, and each neuron has on average around 1,000 connections to other neurons within the nervous system. Neurons come in all shapes and sizes, and they communicate with one another through a process called neurotransmission. There are many different neurotransmitters, each having different roles and actions. Some involved in pain management, learning and memory, general levels of alertness and focus, or feelings of pleasure you get from something if it goes well. The process of neural transmission begins with the information coming in at one end through the dendrites being processed or summed in the cell body, and then being transmitted down the axon, out of the axon terminals, where the message can be passed along to other cells. This allows for communication with one another and ultimately with, communication with muscles in the arm or hand, for example, and it's the way we get physical action to occur. So let's go a little deeper with neural transmission and look at what is occurring when the dendrites, when they come close enough to pass message information. You can see the neurons don't touch exactly. Instead, there is a small fluid gap between the neurons, and this is called the synaptic cleft. Commonly, the neuron sending the message is called the presynaptic neuron, and the neuron that's receiving a message is called postsynaptic. As it reaches the axon terminal of the presynaptic neuron, it causes the release of molecules called neurotransmitters into the synapse. Neurotransmitters can be excitatory, meaning they increase stimulation of the postsynaptic neuron and make it more probable to fire an action, or neurotransmitters can be inhibitory, meaning they decrease activation in the postsynaptic neuron and make it less likely that an action potential will be fired. Once neurotransmission has been released into the synapse, a recycling process occurs. The neurotransmitter is recollected and returned to the axon terminal of the presynaptic neuron to be used again in a reuptake process. When neurons fire multiple times in quick succession, this is known as temporal summation. Multiple messages added together in postsynaptic neurons make it more likely to reach the threshold for firing, and the message would be passed along down the chain to get that action to occur. If a neuron receives simultaneous messages from multiple neurons, it can result in spatial summation of the signal. You may receive messages through sensations in the body, combining to make your neurons more likely to fire an action potential so that appropriate actions can be taken at any given time. There's lots to discover in neural transmission process, inclusive of neuroplasticity, which I love, neurogenesis and pruning, all of which assist the brain to communicate, regenerate and learn. Thank you. Bye.